Hey guys, welcome back to Calculus. Sorry, the first version of this video actually didn't have any audio, so we'll try to do this again now. Welcome back, guys. Again, like I said, today is going to be our last day with derivatives of e to the x, a of x, a to the x, ln of x, and log base a of x, okay? There's only one other type of problem that we need to cover, and if you take a look here at the file that you have, questions A and B are going to cover that new format of question. After we cover A and B together, there's just going to be some review, some practice of derivatives here. So you'll have an answer key to follow at some point with those so you can check. And then some application questions that are going to go back to using movement, so position, velocity, and acceleration. And then a word problem, just some applications in terms of a real life example. So I'm going to walk with you through examples A and B on top, and again, then get through the application question, one of them at the bottom. So if you take a look here, what's different about these two problems as you're going through is that if you look at the function that's given, you have y is equal to x to the 3x squared. So we're looking at a problem here where we have x's, and x is not only in the base, right, but x is also going to be here in the exponent, right? So if x is in the base, so something like having x to the second power, we know how to take the derivative of that. And if we have x in the exponent, like if it was 2 to the x, we know how to take the derivative of that. So it would be just times ln of 2 or ln of the base. So when you see something like this is completely different because now we have x's both in the base and in the exponent. So you're going to have to take a little bit of a different approach here, okay? Because what's going to happen is this exponent cannot stay up there. We're going to have to get that exponent out of the exponent. We're going to have to bring it down somehow. If you recall, okay, if we had the natural log of x to the a power, we had a log rule that said that we can take that exponent and move it out front as a coefficient. We're going to use this rule. This rule is going to be very important for us in this type of problem because we're going to use it to bring that 3x squared out front. If we want to do that, however, we are going to have to take the natural log of both sides. So here we'll have the natural log of y is equal to the natural log of x to the 3x squared. Now that we have that exponent that's up here, that can come out front as a coefficient. And we have the natural log of y is equal to 3x squared times the natural log of x. Once we have this, we now have an equation, okay, that's written implicitly, right? We have x's and y's jumbled together, and specifically this y is inside that natural log, so we're going to have to do a little bit of work here with some implicit differentiation. Let's start with the left-hand side. When taking the derivative of the natural log of y, we have 1 over y, or 1 over the argument. Don't forget, however, that we're going to need the chain rule for the argument, and we're going to have to multiply this by dy dx. That's like having your u prime, or 1 over u prime, okay? Now, on the right-hand side, we have a product of two different functions, so we're going to have to use our product rule. So we have the first times derivative of the second, or 1 over x, plus the second times the derivative of the first. Oops, so that should be a 6x. Okay, so we can clean this up and we can say, all right, we have 1 over y times dy dx, and that is equal to, this will simplify to 3x plus, and I'm just going to write the 6x in front, ln of x. The only thing is that we're solving for y prime, aka our dy dx, so we got to get that expression alone. Notice on the left-hand side, we still have this guy here. We're going to have to bring that over to the other side. The way to get rid of that is to multiply both sides by y. On the left-hand side, note that the y's will cancel, while on the right-hand side, just don't forget that that has to be multiplied to the entire side. So we have that dy dx is equal to y times 3x plus 6x ln of x. The only thing is here, when you're taking these derivatives, notice that this was written explicitly, meaning that we have y equals and then a whole bunch of x's on the other side. So for the most part, when they're looking for the answers for these types of questions, we're usually writing our answer in terms of x only. So if you notice that the y expression is equal to that, right, x to the 3x squared, all we're going to do to wrap this up is just replace y with x to the 3x squared. And then we're going to rewrite it, 3x plus 6x ln of x, or the natural log of x. And that will be your final answer. That is it. Okay, so again, we're really just taking the natural log of both sides to bring that exponent with the x out of the exponent. And then we're trying to use implicit differentiation, again, to solve for dy dx. So let's go through one more example before you're left to practice derivatives on your own. If we take a look here, again, we have x's in the base and x's in the exponent. So that's going to be a problem for us. We don't have rules that deal with x's in the base and in the exponent. So we're going to have to take the natural log of both sides. So we have the natural log of y is equal to the natural log of x to the ln of x. Notice this exponent can now come out front as a coefficient. So the natural log of y equals the natural log of x times the natural log of x. We can now use our implicit differentiation. This will now be 1 over y times dy dx, using your chain rule, is equal to, and here we have another product rule. So we have the first times the derivative of the second plus the second times the derivative of the first. Notice that both of these expressions will become the natural log of x over x. Okay, that x times that 1 over x doesn't occur because that x there is inside the natural log, right? It's kind of like having a function notation. Notice that these two terms, however, are exactly the same. So therefore, we're just going to have two of these when we combine. On the left-hand side, we still have 1 over y, dy dx. And last but not least, we're going to multiply both sides by y to get rid of that and isolate your dy dx. Just don't forget, as you're doing this, we do want to replace the y with the x to the ln of x. So we have 2 times x to the ln of x. Let's just write that a little bit nicer. The natural log of x times the natural log of x. So I really just put the y after the 2 there. That's all going to be over x, and that would be your final answer for this particular case.